Please subscribe to the channel. So our topic is Newton forward interpolation and Newton backward interpolation. So let us take example in these two things and see how that will help us. The first thing I would like to introduce in this course is the Newton's formula, because for us to deal either with Newton forward interpolation or Newton backward interpolation, we need to get versatile with the formula for both of them. Of course, they are similar, related, but they are not the same. So we have to pay attention to every single sign that we see, as that determine how accurate our result will be. So let's take the formula for Newton forward interpolation. Newton forward interpolation is given by this formula nx. Of course, it represents the function. This exactly is the function, and the function is given by y0. We have y0, so the function will be given by y0. Y0 plus p. P will be a constant. Of course, we are going to find the value of p, and the first forward interpolation is given by p by this del. This is represented by the first forward interpolation. Of course, p into p minus 1 divided by 2 factorial, and this is for the second forward interpolation. When it is 3, we simply say p into p minus 1 and p minus 2 into third factorial, and this is for the third forward difference, and we continue like that up to n. Here we are going to evaluate the value for p, and to do that it is simply x value minus x0 represented divided by h. H is simply the interval in the table. So let's take a question and see how we can put all these things into practice. So the first example here, we are to find the value of tan. And this tan is given by 0.12. In the table, of course, the table is x and y. So x has its value to be 0.10, 0.15, 0.20, 0.25, 0.30. Y is equals to tan x, because we are to find the value of tan at 0.12. So y is equals to tan x. Of course, it corresponds to x value. So when it is 0.10, it is simply 0.100 up to 0.3093. So let us find the value of tan at 0.12. When you are given this type of question and you are required to use Newton forward interpolation, you simply need to first of all construct your table. At any point in time, you can pause the video and try doing it yourself. So let us have a table of x and y value, and then determine the value of tan at 0.12. This is what our table looks like, because these are our x and y value. If you remember, we have x to be 0.10, so x is simply 0.10. We arrange them that way, and then we have in the second column we have our y values, and then we arrange them according to what we are given. In Newton forward interpolation, or even in Newton backward interpolation, what we are simply required to do in this table is to take their differences. So the first forward will be this value, the second value minus the previous. So this will be 0.1 511 minus 0.1003, and this gives us the first forward difference, which is 0.0501. If we take these two differences, we get 0.0516. 0.2553 minus this will give us this difference, and this is how we get the first forward difference. In the second forward difference, we simply take the two differences, 0.0516 minus 0.0508. This gives us the 0.0008. We do the same here, we get this, and this is what we have. In the third forward difference, we have got the differences between these two and the differences between these, 0.0014 minus 0.0010. This gives us 0.0004, and if we take these two differences, we will simply have 0.0002. We cannot go beyond this fourth difference because we have got only one term in our fourth differences. So this is exactly what we have, but remember, we are evaluating the Newton forward interpolation. So the Newton forward interpolation, meaning that we are going to take our values from these first columns. So our values will be from these first volumes, and you can see how it is indicated. So we are taking our values from this. So this will help us now to evaluate our first value for Newton forward interpolation. So when you have this down, you simply plug it into the formula. Remember, in our formula we've got y, the function will be equals to y naught plus this first forward plus second forward divided by 2 factorial up to the fourth, because we've got up to the fourth. So if we apply Newton forward difference interpolation formula, we will simply have this, but to do that we first of all need to evaluate the value of p. So p is given by x minus x naught divided by h. Our value for x is given in the equation because we are to evaluate tan at 112. The equation says find the value of tan at 0.12. So this becomes our x. So if that is our x, what is our x naught? Our x naught is taken from the table, and we know that the table, we have this as 0.1003, so we have 0.10. This becomes our x naught, so we simply plug into that. Divide this by h. H is simply the interval, so 0.15 minus 0.10. If you check the interval of these two, it is 0.05. So 0.05 is the interval that we are given in the table. So evaluate these two things, you will get 0.4. So p, our value for p is simply 0.4. Plug in this value in this equation, in the formula. We will simply have y naught plus 0.4, which is our value for p. Multiply this by the first difference and follow suit until we reach the fourth time as we have in the table, so that our y of x will be given by 0.1205. And that's how we deal with Newton forward interpolation. So let us now consider Newton backward interpolation. For Newton backward interpolation, note that you can notice that in our formula, the only difference between Newton forward and Newton backward is that in the formula here we've got addition, but in the formula for Newton forward it is a subtraction. We use minus here, but in for the Newton backward it is simply addition, and we continue up to by how many terms we have. Of course, we are going to find the value of b, but here instead of x naught, it has become xn, and we divide this by the interval that we are going to be given in the table. So let us take an example. Consider the tabular values and determine y at 300. Y at 300 simply means that y is equals to x. So our value for x will be 300. Of course, it will be minus xn, and our xn simply in this table will be 50 divided by the interval. The interval will simply be 100 minus 50. You take the differences, and that will be the interval in this table. So let us construct the table first. If we construct our table, it looks this way because we are simply taking the difference between 618 minus, that is 724 minus 618 will give you 106. If you do the same here, you have 101. In the second for backward, because this is backward, you will simply have 106. We have 81, so 81 minus 106 is negative 25. But note something here. I want to point out something. Note that if you observe in these symbols, this is for backward, this is for backward, this is not the same as the one we had for forward. In Newton forward, it is upright, but in Newton backward, it is upside down. So this is the sign we use for Newton backward interpolation. Of course, we are going to calculate using the last column, and this is where we got our values from. When you take the differences, you have the first forward, the second forward, the third forward, and the fourth forward. So simply take this and plug in into the formula that we are given. So apply Newton backward difference interpolation after finding the value of p. Of course, I've told you in the beginning that 300 is our x and 250 is our xn from the table. From the table, you simply need to go to the table. Then you are able to take the value for we are using this last value because it is backward, so this becomes our xn. We should have used 50 if it were to be forward interpolation, but since it is backward, you use 250. So 250 is our xn, while 300 is our x divided by the interval. Of course, the interval is 50. So if you do this, our value for p is 1. Plug it into this formula so that we are able to get our value for p, and our value for xn at 300 is simply 1148. And this is how we deal with Newton forward and backward interpolation. Hope you have enjoyed the video. You can watch my previous videos on how we derive the formulas for Newton forward interpolation and Newton backward interpolation, and you'll be good to do. Next video we'll continue with the series and bisection methods. See you, and God bless you. Galagash.